Welcome to the Transforming and Analyzing Data in the Data Lake webinar. My name is Gareth Eager, and I'm an Enterprise Solution Architect with AWS based out of the New York City office. In this webinar, we're going to look at how you can optimize analytics of your data lake by transforming your data into optimized file formats and by considering partitioning strategies. We will also look at some of the tools available in AWS for performing analytics and how they may be suited for different data consumers in your organization. Data is changing, and as a result, analytics are adopting. The way that organizations are doing analytics today is very different to how they were being done 10, 15, 20 years ago. While we come from a time where things were done in batch and perhaps overnight, we're moving towards far more real-time use cases for our data analytics. There are new types of data that need to be processed by modern analytic frameworks. For example, if you're a realty company, you may have thousands or hundreds of thousands of photos of houses or properties that are for sale. Using machine learning tools, you're able to extract metadata from these photos and record things like what is in the photo, whether it's a bathroom or a kitchen, other colors that you may be able to extract the metadata about. And you can use these to combine with analytics from your web server to determine what photos appeal most to users, and then use that information in future marketing initiatives. So these are new types of analytics, new types of data that we need to work with, and as well as other data types such as streaming, data from social media, including Facebook and Twitter. And so AWS data lakes help address these modern challenges to the analytic environment. AWS provides tools to help you quickly ingest and store multiple types of data. There's a wide ecosystem of tools to use so that you can use the right tool for the right job without manually needing to copy data around between systems. And then there's many tools that help provide deeper insights and provide governance and security for your data lake. The heart of the data lake on AWS is the Amazon S3 storage service. And built around that are many tools and services around the data lake ecosystem. So there are tools for bringing data into the data lake, things like Direct Connect, Snowball and Snowmobile. There's ways to bring streaming data and real-time data into the data lake with things like AWS IoT Core and Amazon Kinesis. There are many different tools for doing analytics, and we're going to look at some of those in more detail later on in the webinar today. And then around machine learning, there's a rich set of tools to use on the data in the data lake for predictive analytics as well. When data lakes were first becoming a popular concept within organizations, there was often this misconception that data lakes automatically and immediately solved all the problems that had existed with previous ways of working with data. There was this idea that perhaps if we just brought all the data together into a central place, there would somehow be some magic way that people could get value from that. But over time, many organizations have realized that it's not that easy. Data lakes really do make it easy, though, to ingest data, to get the data into a centralized repository and to put that onto affordable storage. However, to really extract value from the data, additional work needs to be done. So curated data sets ultimately need to be created to enable both optimized analytics and to avoid the data lake becoming a data swamp where there's all these different data sources, but no one is sure what they can trust, what the source was, where it came from. And so some of the activities that need to be done once the data has been ingested in a raw format into the data lake is to catalog the data and make that metadata searchable throughout the organization, and then to compress and partition the data to optimize the analytics that are done in the data lake. Often, data will also be denormalized or flattened to increase the performance and the efficiency of those analytic tasks. So AWS Glue, along with AWS Lake Formation, are tools that are used to help with the ingestion of data, cataloging the data, and then performing ETL and transformation on that data. So the Glue or Lake Formation data catalog is able to automatically discover and infer metadata from data that has been ingested into the data lake. The crawlers can automatically crawl a location in S3 or in a JDBC database or in DynamoDB, infer the schema, and then record that information in a centralized catalog. The catalog is then searchable and available to be used by other analytic tools for querying the data and for performing ETL. Glue also includes an ETL engine for doing common transformations of the data. Glue provides a serverless Spark cluster environment where you can write ETL code to optimize your data. One of the most important ways to optimize data for analytics is to have the correct file format for analytics. So text format is great for when somebody needs to review data and to be able to open a data file in their favorite text editor. However, a text format, whether that's CSV or JSON or XML or many other formats, is not optimized for machine analytics. And it really is, when you're talking about big data, you're using various systems and services and applications to do the analytics on the data. So over the past few years, Parquet and ORC have become popular file formats for data analytic tasks. These files are stored in a compressed binary format. So by reducing the size of the files, this leads to optimizations and performance improvements in the queries, and also reduces storage costs and query costs. Parquet and ORC have integrated indexes and statistics that also help improve the performance of analytic jobs. These formats are written to disk physically based on a columnar format. So this means that when you're doing a query or when you're using an analytic engine to query files written in Parquet or ORC formats, only the columns that are being queried need to be physically read from disk. And this can lead to significant performance improvements, as we will see as we go through the webinar. Another common format for files is Avro, which, like Parquet and ORC, is a file format that is compressed in a binary format. However, Avro is optimized for read performance when selecting all the columns across a subset of rows. So for the purposes of our discussions today, we're going to be focusing more on Parquet and ORC as the analytic file formats we want to use. Another common strategy for improving the performance of analytic queries is to use data partitioning. This is where you separate the data files by any column that is in the data set, and then the analytic engine only needs to read the data that is needed by the query. This reduces the amount of data scanned, which in turn can improve the performance of the query and reduce the query cost. And this works for both text files like CSV or JSON files, as well as files that are column-based, such as Parquet and ORC. Let's look at an example of partitioning. Here we have some flight data stored in AWS S3 in Parquet format. And we've partitioned this based on the year, which is a common partitioning pattern. So in this case, all the information relating to flights for the year 1987 are in the S3 prefix or directory, year equals 1987, and so on for the other years. So when we run a query such as select destination, origin from flights, where year equals 1991, the analytic engine only needs to query and read the data that exists in the prefix or directory year equals 1991. When looking at a partitioning strategy, you want to choose a column for your partitions that has low cardinality or uniqueness. So a common pattern here is to partition on day, month, and year, and that would give you 365 unique values or partitions per year. Even if you stored 10 years of data, there would be 3,650 partitions, which is a relatively low amount. Now, if you had IoT data coming in and you had a lot of data coming in every second, but you wanted to look at partitioning per second, that would obviously have millions of values per year, and that would not be a good choice for your partitioning strategy. Also note that you can partition on any column, not just the date column. So for example, if you have data that you store by country and then state and business unit, because you're doing queries that often follow those patterns, then the example shown here could be a good query pattern. So this would enable you to query by an entire country to, let's say, see the sales figures for the United States. And then you could refine that. And if you were doing a query just by the state of New York, you could query by country equals US and state equals NY, and we're just querying a smaller subset of data. And then if you just need to query the business unit data for a specific business unit in New York, you could use the third level and really further limit the amount of data that the analytic engine needs to read. Ultimately, when deciding on a partitioning strategy, you need to understand what your queries are going to be. Do your queries regularly use the same column in the where clause? If they do, then partitioning your data may lead to further performance improvements and reduced costs. But if you have a wide range of queries and you have ad hoc queries that are regularly using multiple different where clauses against different columns, it may not always be worthwhile to do partitioning of your data. The most important advice that I would give is to make sure you use a file format that is optimized for analytics. So something like Parquet. Ultimately, as you set up your data lake, you'll find a common pattern here is to ingest data into a raw data area, to then have something like the AWS Glue crawlers run against that data and to populate the Glue data catalog. You then may have a Glue job that does some ETL transformations, perhaps transforming the files into Parquet format. And if you've got very large data sets and you understand the query patterns where partitioning makes sense, you then partition your data into a staging data area. And then there may be further ETL tasks where you're using Glue to do additional enhancements to your data or enriching the data with other data sources, and ultimately creating data sets that are useful for different analytic groups within your organization. You then have the wide variety of analytic tools available in AWS that you can use to query those data sets. And so services like Athena and QuickSight, Redshift, SageMaker, and EMR are able to use the lake formation or Glue data catalog to query the data in the data lake. So one of the analytics services that we've mentioned and I'd like to talk a little more about is Amazon Athena. And this is an interactive query service that makes it easy to analyze data directly from Amazon S3 using standard SQL. So a typical user of Amazon Athena is the data scientists in an organization, as well as data analysts who are doing data exploration or needing to run SQL analytic queries on data in the data lake. So Athena is this interactive query service that you're able to immediately start issuing SQL queries against data once that data has been cataloged in the lake formation or glue data catalog. So you're able to, with zero setup costs, just start running queries using the cataloged data. With Athena, you only pay for the queries that you run, and so you're saving 30 to 90% on per query costs by using optimized file formats such as Parquet, which is compressed. And Athena provides a open ANSI SQL interface that you can access both through the AWS console, or you can access using JDBC or ODBC drivers. So for example, you can use SQL Workbench to connect to Amazon Athena to run SQL queries against the data in the data lake. And with Athena, it's all serverless. There's zero infrastructure to set up, and there's zero administration of any infrastructure related to Athena. So let's have a look at a quick demo of Athena, and this will also show the power of using optimized file formats like Parquet. So I have some data in S3. There is the GDELT open dataset that is made available as a public dataset in AWS. This data set is around about 150 gigabytes in CSV format and is available openly on AWS. So what I've done is I have used AWS Glue to transform that data and create a copy of that data in Parquet format. So if we go into this S3 location, we will see here we have Parquet files that have been compressed with snappy compression. And we've taken the 150 gig, approximately 150 gig of CSV files and compressed it down into around about 38 gig of Parquet files. I then used the crawler to both crawl the original CSV data set that is publicly available on S3. And then I also crawled the location where I created a Parquet copy of that data set. So within the catalog, I now have both events and events Parquet tables available for querying with Athena. So once the crawlers had run to go and discover this data and add it to the catalog, I'm able to go into AWS, into Amazon Athena, and run queries against that data. So let's run a query that just counts the events from the events table, which, as you may recall, is the CSV version of this data set. So running this now, Athena is querying the CSV files on Amazon S3 and counting the number of rows effectively that is contained in those CSV files. And we get our results in just over 15 seconds, and we can see that we scanned nearly 190 gigs of data. Let's now run a query where we count the events against the Parquet version of that data. So we're running the same query here, but this time we're specifying the events Parquet table, which obviously points to the data in S3 that is in Parquet format. So running the same query to do a count, you can see runs in just over 4 seconds compared to when we ran it for the CSV version of the data, and it took just over 15 seconds. So straight away, you can see that there are significant performance improvements by running queries against optimized formats such as Parquet. You also note here that the amount of data scanned was 0. And that's because, as I mentioned earlier, Parquet files store metadata about the data in each file as part of the file. So for example, within the Parquet file, the analytic engine, in this case Athena, can open the file and read from that metadata how many rows is in each file. And so without actually having to scan through all the data and to scan through all the rows, analytic engine is able to open each file, read the metadata, and do a count on the number of rows that is in that data set. With Athena, the price is $5 per terabyte of data scanned. So you can see here how this also helps reduce the costs. For our first query against the CSV files, we would have paid to scan 190 gigs of data. In the second query, counting these events, there would be no cost because there was no data that was scanned. Let's look at some other queries we can run here to compare more complex queries with CSV files and with Parquet files. So to start with, we're going to run a more complex query here that goes against, it joins two tables, both the event table in CSV format, as well as an event code lookup table that is also in CSV format. But the event code table is a very small file with perhaps 50 or 100 records in it. And so we run this query to go and count the total events for each event code in the data set. So right now, the query is running again against the events table. So this is the CSV version of our data. And we can see that this query completed in 14 seconds. And again, it scanned the entire data set. So a full 189 gigs was scanned to return this list of the events, the top 20 event codes and the total number of events for each event code with a lookup. So we don't just get an event code, but we're able to see the description. Let's run that same query now against the Parquet version of that. So the query here is exactly the same, except this time we're querying the events Parquet table, which, as you know now, is stored in S3 in Parquet format. And we can see that that same query here took just over 5 seconds to run and scanned a total of 452 meg. So comparing to CSV, 14 seconds and 189 gig for CSV, but 5.5 seconds and 452 meg for the Parquet version of the file. So we see significant performance improvements and we see significant cost reduction by using something like Glue to transform our files into an optimized version like Parquet. So one of the best practices when working with Athena is to use optimized formats like Parquet, to use partitioning, but there are a number of other best practices that you should consider when using Athena. And so I'm including a link in the slides, which will be available as a PDF, or you can just do a Google search on the top 10 performance tuning tips for Amazon Athena. So let's talk about some of the other analytic tools that are available within AWS and integrated with the S3 data lake ecosystem for doing analytics. So Amazon EMR is a managed cluster platform that simplifies running big data frameworks. And the two most popular ones there are those within Apache Hadoop and Apache Spark. So typical users here would be data scientists or data engineers who need to process and analyze vast amounts of data using open source projects or to do ETL functions. When you launch an EMR cluster, you have access to a diverse set of analytic tools. So at the time of launching your cluster, you can choose which frameworks or tools you would like to make use of in the cluster. So there are tools such as Hive and Pig for batch and script work. There's Spark and Presto for interactive analytics, as well as Spark for real-time analytics and machine learning. And so there are many different use cases that EMR is able to assist with. Things like log and clickstream analytics, machine learning, even genomics and ETL. In total, there are 19 open source projects that are available as part of the EMR cluster at launch time. Enterprise-grade security is built into EMR, and the latest versions of these frameworks are made available generally within 30 days of release. The various strategies for keeping the costs low when using EMR compared to running these type of environments on premise. So for example, you're able to use EC2 spot instances, which provide some excess capacity from our EC2 fleet at reduced cost. You can also use reserved instances and then auto scaling to reduce costs between 50 to 80%. EMR is integrated to be able to use the Amazon S3 storage and integrated with the catalogs that are formed through glue and lake formation, so that it's very easy to start your cluster and then to start using things like Spark SQL to query data in the data lake. Within the analytics environment, there is still certainly a place for data warehouses. And Amazon Redshift is a fast, simple, and cost-effective data warehouse that has the ability to also extend the queries you run beyond just the data warehouse and to the data lake. So a typical user here is a business analyst that's wanting to load frequently queried data into a high-performance data warehouse for dashboard and other operational reporting or ad hoc querying. Now, data lakes are different to enterprise data warehouses, and yet they do not exclude each other. It is a common pattern to see organizations build out a data lake and then also load a subset of that data into a data warehouse. So this table shows some of the differences between data lakes and data warehouses. For example, data lakes, it's schema on read, so it's very easy to ingest diverse data sets into the data lake. With the data warehouse, you need to define the schema up front, and so you need to put more planning and thought before you're able to ingest your data. Data lakes work with structured, semi-structured, unstructured data, where the data warehouse is working with structured data only. Where a data lake, you have flexibility in tools, as there is a wide range, as we're looking at today, of tools that can work with your data in the S3 data lake. In the data warehouse, you have some limited flexibility in the tools that are available, as you're really just using SQL to do your analytics and your querying. So the Redshift as a data warehouse is able to be scaled from gigabytes to petabytes and provide you massively parallel analytic queries. So Redshift also uses a columnar storage technology to help improve I/O efficiency and to scale your queries across very large data sets. And Redshift is inexpensive. It can be as low as $1,000 per terabyte per year, which is 1/10 the cost of traditional data warehouse solutions. One of the big benefits of Redshift is the introduction of Redshift Spectrum, which enables you to extend your queries from the data warehouse to the data lake. And a common pattern we see here is where customers will take the most recent data, maybe some hot data that is queried through BI tools and by a large group of analysts in the organization. So for example, the last 12 months of data, and they will load that on a rolling basis into the Redshift data warehouse. But there will be some queries that still need to access historical data. So there may be some queries that need access to the last 36 or 48 months of data. So using Redshift Spectrum, the data that exists in the data lake and in the data catalog can be made available to the data warehouse queries. And this enables somebody using Redshift to write a query that joins data from the last 12 months that has been copied into the Redshift data warehouse and joins that with tables that live outside of the data warehouse, that live within the S3 data lake. And yet the same query can run to join the tables in and outside of the data warehouse to produce results. And then we have Amazon QuickSight, which provides a business intelligence tool that is a fast cloud and cloud-powered service. And this makes it easy to deliver insights for everyone in your organization in a very visual manner. So typical users here are business analysts. They want to create and share dashboards with these rich visualizations with both internal and external business users. QuickSight is cloud-based, so there are no servers to manage and no licenses to manage. It's scalable. You can start using just with a few users per month, but you can very quickly and seamlessly grow to 10,000 users. With QuickSight, you're only paying for what you use. You can provide read-only access to interactive dashboards that can be filtered and queried, and you'll pay only when your users access those with pay-per-session pricing. And it's fully integrated. So both with analytic services in the cloud, so QuickSight has connectors for things like Redshift and Amazon RDS, our managed relational database service, as well as S3 and Athena, as well as products from our partners such as Snowflake and Teradata. But QuickSight can also connect back to your on-premise environment to query data sources on-prem, such as Excel or CSV files, or databases that you still have running on-premise. And then there's also connectivity to SaaS applications. So applications such as Salesforce or Square, Adobe Analytics, and Jira, just to name a few of them. So with QuickSight, it's very quick and easy to create interactive dashboards and then share that with other business users throughout the organization. These dashboards can be viewed on any device, so they work as well on a PC or a laptop, as well as via a mobile phone. You're also able to take the dashboards that you create with QuickSight and embed this directly into your own applications. So this lets you enhance your applications with rich analytics and dashboards that are interactive, can be queried and can be filtered. So for example, the NFL has their next gen stats, which is a portal that provides individual passing stats in the screenshot, for example. So a user here is able to filter on different columns and attributes. And this is all powered by QuickSight, but is fully embedded within the NFL Next Gen Stats application. And a discussion of analytics in the cloud wouldn't really be complete without at least mentioning machine learning with the data lake. And while we don't have time to dig into this topic in depth, I did want to mention the wide variety of tools that are available to take the data that you've built into your data lake and to use this for machine learning and for predictive analytics. And so at AWS, we have effectively 3 layers of machine learning that are optimized for different types of users. So at the bottom layer there, we have the frameworks where we have our deep learning AMI that you can launch on an EC2 instance and get access to pre-compiled and optimized machine learning frameworks such as MXNet, TensorFlow, and so on. The layer above that is our platform layer, where we have various services that can be used by developers to get going with machine learning tasks and to do complex machine learning. So Amazon SageMaker helps developers with training of machine learning models, model development, and then also hosting the model so that you can have hosted inference, or you can use SageMaker for batch inference as well. And then at the top, we have various machine learning services where we have pre-trained models that can be used by developers through a simple API call. So for example, with our Amazon recognition service, a developer can make an API call pointing to an image file that exists on S3, and the recognition service will use the machine learning model that we have developed and trained to automatically extract metadata from that image. So things like what objects are in the photo, or if it's a picture of a person's face, are they happy or sad, or various other attributes from that. And we've got similar services around both for vision, for speech, for language, and then Amazon Lex for creating machine learning powered chatbots. So as you build out your data lake on AWS with S3 at the heart for the storage of your data, I hope this webinar has been able to show you some ways that you can optimize your data for increased analytics and reduced costs. And so you, as a summary, using file formats such as Parquet can lead to significantly increased performance, as we saw earlier on in the demo. And then if your data set is right for it, if you understand what your query patterns are and you're commonly querying with the same where clause, then using partitioning can further increase the performance and reduce costs. And while we weren't able to get into all the services today, we did discuss a number of services to help with your analytic use cases, from Amazon Athena for ad hoc queries to Redshift as a cloud managed data warehouse, to EMR for Hadoop and Spark processing, and QuickSight for visualization of your data and easily sharing those rich visualizations and dashboards with the different data consumers in your organization. Thanks for taking the time to join us for the webinar today. Hope you learned something, and we should have some time now to take some questions.